Today we're going to be talking about triangles, specifically how to classify them, and then some rules that we have about angles. So to start with, what is a triangle? A triangle is a shape that has exactly 3 sides. The sum of the measures of the interior angles of the triangle, of which there are 3, is 180 degrees. Triangles can also be classified by either angle or side measurements. So let's start by classifying them by angles. Our first type of triangle is the acute triangle, which we call because it's just so adorable. It's such a cute little triangle. Or possibly because all the angles in the triangle are less than 90 degrees, or acute. It's one of the two. Who knows which one? Too much debate to find out. Next, if we go a little bit bigger than an acute triangle, we get to the right triangle. A right triangle is very simple. It has exactly one right angle, which means because one of the angles is 90, the other 2 angles end up actually being complementary. For those of you that have forgotten, complementary means 2 angles that add up to 90 degrees. So 180 minus 90 leaves 90 for the other 2 angles, so they are complementary. We also have the obtuse triangle, where a right triangle had one right angle, an obtuse triangle has exactly one obtuse angle. Our final way to classify based off of angles is what we call equiangular. Equiangular triangles are acute triangles where all 3 angles measure exactly 60 degrees. Now, if you're looking at this triangle and thinking, isn't there another name for this? I don't feel like I've learned this name. It's because we also tend to call equiangular triangles equilateral, but that is for a different type of classification. If I ask you to classify based off of angle measurements, you would call it equiangular. Now, we're going to talk about classifying by sides. Our first type of triangle we're going to talk about when it comes to classifying by sides is the scalene triangle. A scalene triangle has no sides with congruent measures. So a 3, 4, 5, for instance, would be a type of scalene triangle. Second, we have what we call an isosceles triangle. And I should warn you, there's a decent bit of information that we need to know. The first thing that we need to know is at least 2 sides are congruent. Now you might notice I said at least. That's going to come back in on a slide very soon. The congruent sides are what we call legs. So I'm just going to mark those right here, leg and leg. The third side is what we call the base, and it is all about that base. Now, the angles opposite the legs are what we call base angles. So here's what I'm talking about when I say opposite a leg. So let's look at this leg that we have right here on the left side. If you look, it is formed by this angle. This is the angle that is not touching the leg, and it kind of goes out to the exact leg that we're talking about. So this would be the base angle to this leg. And then alternatively, this other side is where the base angle would be for the right leg. Now we do have a third angle in any isosceles triangle, and that is called the vertex. It is opposite the base. And it is formed by the 2 legs. Oh, one very important piece of information that I forgot to put on here that you should put down. The base angles are also going to be congruent. All right, so our last type of triangle that we're going to discuss is the equilateral triangle. This is the one that I said was also equiangular. The difference is equiangular, we were talking about the angles. Equilateral, well, it's a special type of isosceles triangle where all 3 sides are congruent. So with equilateral, we are talking about these sides. It's also equiangular. All right, so what we're going to do now is we are going to classify each of these triangles by their angles. So the first one here, it says, is triangle DBC. Now, if we look at this image right here, you'll notice that there are quite a few different possible angles that we have. But we're going to start with DBC, which is this triangle right here. Now, if I'm wanting to classify this triangle, I would look and I see that my three angles are 70, 90, and 20. Since one of them is 90, that makes it a right triangle. Now let's look at our next one. We have ADB. That is this triangle right here, the one that was adjacent to the triangle that we started with. If we look, the two angles that we see are 59 and 31. But there is a third angle, and that's actually found by the adjacent angle that was 90. So in this case, this angle is also going to be 90, but if we weren't sure, we could do 31 plus 59 and discover that that's 90. And since those two angles are 90, that leaves us with a third angle that would be 90 degrees as well, meaning this is also a right triangle. Finally, we have ADC, which is this giant triangle formed by our two smaller triangles right here. So let's look at what our angles are. So we have a 59, we have a 20, and then we have this 31 and 70. Now, you might be going, all of those are acute. Yes, but this angle is formed by both. 31 plus 70 is 101 degrees. 101 degrees makes this triangle obtuse. All right. So now let's classify these three by sides. So our first one is going to be EGH. This is the big triangle in this case. So let's look at some information that we know. We know that this line right here is 8 and that this line is congruent. So these two lines are both 8, meaning at the very least it is isosceles. But let's see if we can be more specific and say equilateral. So I look at my third side, and as you can see, it's right now being split into two equal sections of 3. Unfortunately, 3 plus 3 is not 8, which means we cannot call it equilateral. Instead, we just have to call it isosceles. Now our next triangle is going to be EFG, or EFH. EFG would just be a line. EFH has side measures of 8, 3, and 7.4. That makes this triangle scalene because all three sides are the same, are different. Finally, we have HFG. And if you look, this is actually going to be a congruent triangle to EFH. HFG has sides of 7.4, 3, and 8. Therefore, it is also scalene. Sometimes I might ask you to find the side lengths. So let's talk about how we would set this up in case you see questions like this in your homework or on tests or quizzes. So in this case, if you look, the type of triangle that we have is an equilateral triangle. In this case, one of the sides is 6y and the other side is 4y plus 12. Now, in class, a lot of people were asking me, but Mr. Peacock, these are different lengths. How can we say that these are in fact the same? And the answer is, remember, we need to find a value for y which makes these the same. So to do that, I have to set this up as an equation. Now, if I had told you that this was, say, 36, you would say 36 equals 4y plus 12. But in this case, we're just going to set it up as an equation where it's one side equals the other. So 6y equals 4y plus 12. Now our first step is to get all the y's on the same side, so we would subtract 4y, which gets us 2y equals 12, which means y equals 6. Our last step is to plug it in, because remember, we are not finding the value of y. We are finding, as it says right here, the length of the sides. So we plug y back into 6y. 6 times 6 is 36. Now let's double check and make sure that this is going to work. This side said 4y plus 12. If our answer is correct, this side should also equal 36. So let's see, 4 times 6 is 24, plus 12, sure enough, gets us 36, meaning all three sides of this triangle are that value. Now, here's another equation. We have 4x plus 0.5, x plus 2.4, and 2x plus 1.7. If we look at this equation, at first you might think, isn't there too much information? Don't I have three equations where I should only have two? And that's because one of these equations is not yet useful to us. It will become useful after we solve for x. But for now, we do not need 4x plus 0.5. That said, I'm going to keep it out there so that we can see it later. The reason why we don't is, if you look, we only have the hash marks that symbolize congruency on x plus 2.4 and 2x plus 1.7. Meaning, the way that we would set up this equation is x plus 2.4 equals 2x plus 1.7. So my first step is to subtract x from each side. 2.4 equals x plus 1.7, and then subtract 1.7 from each side. 0.7 equals x. So if x is 0.7, what I do is I plug it in just to double check. So 0.7 plus 2.4. Now I know some of you are probably not sure how to add decimals as well. You know how, but it's just not something that you can naturally do in your head as well as I would like. So what I would recommend at that point is convert everything into just whole numbers and then move the decimal place back to where it should be at the end. So 0.7 would become 7, 2.4 would become 24, and you would get 31, but when we move the decimal point back, we get 3.1. 2 times 0.7 is 1.4, 1.4 plus 1.7. What you will find is you actually end up getting the same value of 3.1. So those two equations are equal. So now let's find out what the third side is. It's possible that this could be equilateral, but because they didn't put the hash marks, we don't know that just yet. So what we would do is we'd plug this in. 4 times 0.7 ends up being 2.4. 2.4 plus 0.5 gets us 2.9. So our three sides are 2.9, 3.1, and 3.1, meaning this triangle is simply isosceles. Now let's talk a little bit about the exterior angle theorem. So whenever we talk about triangles, normally you only think of our three interior angles. Angle 1, 2, and 3 in this picture. Those are the ones that you normally know about. We know that these three angles add up to be 180 degrees. But we have another triangle, another angle right here. So if we extend any side of a triangle, we end up getting an exterior angle. In this case, 4. So what I would like us to do right now is I would like us to know some things. So like I said, this is called the exterior angle. And we also have two angles that are going to matter a lot inside the triangle. These are what we call the remote interior angles. Now, if you think about a remote, like if I say a remote control or a remote controlled car, remember, those are things that you're controlling without actually touching them. A remote control car will not have some long cord coming from the control. So, in this case, we have 1 and 2. Those are what we would call the remote interior angles. Now, there is a rule that we're going to learn about when it comes to the remote interior angles. So, let's first remind ourselves of what we just said. The three angles in a triangle add up to be 180. So, in this case, I could say angle 1, the measure of angle 1, plus the measure of angle 2, plus the measure of angle 3, equals 180 degrees. Now, if I wanted to get the measure of angle 1 plus the measure of angle 2 all by itself, I would subtract the measure of angle 3. So I would say the measure of angle 1 plus the measure of angle 2 would suddenly equal 180 degrees minus the measure of angle 3. Now let's talk about the relationship between this exterior angle and angle 3. If you look, these two angles form a line. They're what we call a linear pair. Now you might remember from when we learned about linear pair that linear pairs are what we call supplementary. And just like complementary earlier we said added up to 90 degrees, supplementary adds up to 180 degrees. Like I said, you can see that because they form a line. So in this case, what I would say is the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Now, if I wanted to get the measure of angle 4 by itself, what we would do is we would subtract the measure of angle 3, much like we did before. And I would get the measure of angle 4 equals 180 degrees. Now, some of you might be going, okay, Mr. Peacock, I guess that's true. But what good does that do us? There's absolutely nothing of value from what you just said, except here's the thing. The measure of angle 4 equals 180 minus the measure of angle 3, and the measure of angle 1 plus the measure of angle 2 also equals 180 minus the measure of angle 3. Now, I know you all love proofs so much, as we all do, but one proof that you might remember is called the transitive property. The transitive property was basically if one thing equals something and another thing also equals that, then they have to equal each other. So if A equals B and B equals C, then A equals C. So in this case, the measure of angle 1 plus the measure of angle 2 is equal to 180 minus the measure of angle 3. And if you look, the measure of angle 4 is equal to that same thing, 180 minus the measure of angle 3. We've gotten them equal to the exact same thing, which means the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. Or the sum of the remote interior angles is equal to the measure of the exterior angle, which is our exterior angle theorem. Now I know when you look at that, you go, oh, Mr. Peacock, that was so helpful. Thank you for all the help. Definitely, I understand it all now. Well, in case that's not the case for you, let's go back a little bit and try out a couple things that might actually make this make a little more sense. Now that we've established this should work, we're going to just create a triangle and actually see what the measures work like, just to make sure that, it makes any sense. So what I'm going to do is I'm going to say that the measure of angle 1 is 50 degrees. The measure of angle 2 is going to be 60. And the measure of angle 3, because 50 plus 60 is 110, is going to have to be 70 degrees. So we already have angle 4 drawn out. Angle 4, if angle 3 is 70, has to be 110 degrees because they are a linear pair. And if we look at this, 50 plus 60 does equal 110. But you know what? The thing is, that just proves it works once. If all we do is prove that something works once, we haven't actually proved it works at all. Because if all I did was say a right angle, an example of a right triangle is a 3, 4, 5 right triangle, you might think that all numbers, if they just go one after the other, would create right triangles, which is not our rule. So what I'm going to do is I'm actually going to extend the line at angle 2, creating us a new angle, which I would call angle 5, but since we're going to just have a value for it, I'm just going to say the value. So in this case, we have a 60-degree angle, so when we extend out the line, the other angle, the angle that would be 5, would be 120 degrees. So let's double check and see if that actually works. Our two remote interior angles in this case are 1 and 3, or 50 plus 70. And if you double check, 50 plus 70 is in fact 120 degrees. So this one works as well. But you know what? Let's try all three just to make sure it makes sense. So I'm now going to extend angle 1 out a little bit, and the line's going to go out. So if angle 1 is 50, then that means that its exterior angle is 130, because 180 minus 50 is 130. Now our two remote interior angles, in this case, would be 2 and 3. Those are the two not forming the line with our exterior angle. So 2 is 60, so 60 plus 70 degrees. 60 plus 70 is 130 degrees. So with all three of these, it worked just perfectly for us to see that this actually does work as a theorem. If you don't trust me, come up with a triangle of your own and see if it works for you. All right, so here's an example of a problem you might see that's using the exterior angle theorem. In this case, we have angle M, angle N, and then we have an exterior angle at P, which we would call NPQ. Now, in this case, angle M and N are both remote interior angles. And this angle P is 48 degrees, and it would be our exterior angle. So, if we remember our rule, the sum of the two remote interior angles is equal to the measure of the exterior angle. Now, in this case, unfortunately, we don't have nice, easy numbers. It's not something like 28 and 20, which would be great. Instead, what we end up having to do is we have to add the two together. So the measure of angle M is 3y plus 1. And then the measure of angle N is 2y plus 2. And that is going to equal our exterior angle of 48 degrees. So our first step is that we have to combine all of our like terms. So 3y and 2y combine together to become 5y, and 1 and 2 become 3. So we get 5y plus 3 equals 48. When we subtract 3 from each side, we get that 5y equals 45, which means y is 9. Now, in this case, we are asked to find the measure of angle M. So I don't need to plug this into both angles. I just need to plug it into 3y plus 1. However, if I'm not sure if my math is correct, I can of course plug it into both just to double check that they will add up to 48 degrees. So what I do is I take the original equation, which in this case was 3y plus 1, but it becomes 3 times 9 plus 1, or 27 plus 1, which is 28 degrees. And that would be our answer in this case. Now, for the last thing that we need to learn today, we are going to talk about the third angle theorem. And honestly, this is probably the easiest thing that we are going to be learning today, other than things like triangles have 3 sides, which I think most of you knew. Probably. All right, so in this case, the third angle theorem is something that, honestly, you probably are already assuming when you look at this picture. And that is, if you look at the image that we have right here, you'll notice that angle L is congruent to angle R, and S is congruent to angle M. So if you see that 2 of the 3 angles in one triangle are congruent to 2 of the 3 angles in the other triangle, then the measure of the third angle has to be congruent to the other third angle. In other words, because these 2 are congruent, the third one is too. It makes sense. If I have 2 angles and I know what they are, there's only one thing it can be that will help it add up to 180. So if I know, for instance, that L was, let's say, 70 degrees and M was 30 degrees, then I would know that N had to be 80 degrees. And if I found out that R and S also had those same degrees, then I would already be able to tell you that T would have the same measure as well. And that's the third angle theorem. That's really it. Now, if you would please, if you are in my class, please go into Google Classroom and work on the homework assignment that I've already assigned there. If you aren't, don't know how you found the video, but cool. Either way, that is the end of this presentation. If you would like, subscribe, any of that stuff. Thank you very much. Goodbye.